Today we are going to learn about the applications of the differentiation and the integration. So first we are going to move to the question. The question is the displacement of a particle V from O in a time t is given by s equal to t square minus 5. This is the equation for the distance. So you need to find out what is the velocity of this particle at the time is equal to 5, and you need to calculate the acceleration at the time is equal to 5 seconds, and the last one is that you need to find out the displacement of the particle when the velocity at 0. So you can draw, as mean I will draw. So if the particle is here, so this is the P point. So this particle is moving and it will come to this stage. So this stage means we can notice now 0. So that means O. So the time taken from P to O we mention as T. So this distance, this is S. So that is mentioned in our equation, T squared minus 5. So we will look into the answer. So how can we find the velocity of this particle? So let's move. So you have the equation S equal to T squared minus 5. So you need to get the relationship between the distance and the velocity. So you already know velocity is equal to distance divided by the particular time. So according to the differentiation knowledge, so you can mention this V as a ds divided by dt. Here displacement means the distance difference. That means one point to another point. You need to calculate the difference between this point to this point. So for that we can write V is equal to ds divided by dt. So we can convert this equation into the differentiation. So you already know the equation for the S that is already given in the question. So we can substitute d divided by dt for the S. We can substitute t squared minus 5. So this is the simple differentiation. So you can easily differentiate this one based on the differentiation knowledge. So that answer is V is equal to 2t. So now our question is, you need to find out the velocity at the t is equal to 5 seconds. So you need to multiply with the 5 with 2. So become as a 10 meter second minus 1. This is the velocity. So this is the answer for this question. So second question is, you need to find out the acceleration. For the acceleration also you need to know the equation of the acceleration. So normally the acceleration equation is, so you need to calculate the difference of the velocity. So that is become as a dv divided by difference of the time. So that is become as a is equal to dv divided by dt. For the dv divided by dt equation, you need to know the equation for the v. You already calculate the v in the previous question. So simply we can substitute that. So now the a is equal to d divided by dt. So for the v we can substitute 2t. So now you need to differentiate this equation with t. So now the acceleration become as a is equal to 2. So here this equation is not depend on the time. So we can directly substitute this value for the acceleration. So now move on to the third question. Our third question is that you need to find out the displacement. For the displacement at the velocity is equal to 0. So we already calculate the velocity equation in the above question. That's been the first question. In that question we can substitute velocity now is 0. So we can calculate the time. So time also 0 because right side is left side is a 0. So we can apply this, the t is equal to 0 to the our initial equation. In this question you need to find out the displacement for this question. So we already know the equation for the displacement. So that is equal to s is equal to t square minus y. So here we can substitute t square is as a 0. So displacement become as a minus 5 meter. Minus 5 meter means displacement have the vector. It is a vector. So we need to mention on right side displacement or left side displacement. Here minus 5 means it is moved to the left side. So the answer is minus 5 meter. So this is the application of the differentiation. So next we will move to the integration question. So here, so the question is that the velocity of v of a particle is given by the v is equal to 5 plus e to the power minus t divided by 2. So this is the equation for the velocity. So you need to find out the distance of this velocity and you need to find out the acceleration. So let's move to the answer, how we can write. So you need to find out the distance. So initially you need to find out what is the relationship between the distance and velocity. So we already know. So if you want to calculate the distance, so you need to integrate the velocity. So in the differentiation application, you already know. That means v is equal to ds divided by dt. Now it is reversed. So you need to calculate the s. So if you write ds is equal to v dt. So this is differentiation. For the differentiation, you need to, that means you need to take the real value. So you need to ignore this differentiation. For the ignorer, so you need to use the integration. So if you integrate the ds value, it is become as a s. So the final equation is for the displacement s is equal to v dt, integration of v dt. So this is the equation we already know. Then you have the equation for the v. So we can simply substitute that. Then we can apply the integration rules. So this is the addition. So we can integrate separately. So phi dt and plus. So this is not equal. That is only plus sign. Then integration of e minus t to the power minus t divided by 2. So if you integrate phi dt, it is become as a phi t. If you integrate e to the power minus t divided by 2, it is become as, so we can use this function. That's mean that is the rule of the integration, one of the rule of the integration. So integration of e to the power at dt become as a 1 over a into e to the power at. So this is the integration of the e to the power at. So we can apply this for this particular equation and we can find out the integration of the e to the power minus t divided by 2. The final answer is become as a phi t minus 2 into e to the power minus t divided by 2 plus c. So you need to integrate, so the constant will add. So this is the answer for the distance. Then second question is you need to find out the acceleration. So acceleration means you need to find out the relationship between the acceleration and the velocity. So we already know the a become as a dv divided by dt. That means velocity difference divided by time difference. So we already know the equation of the v. So we can substitute simply. Then after that you need to differentiate this. So you can differentiate as a separate one. So first differentiate the phi, then differentiate the e to the power part, then you can add the value. So the final answer is a become as a minus half e to the power minus t divided by 2. So this is the answer for this question. Okay, thank you.